All right, everybody. Today we're going to be playing around with trigonometric integrals. Okay, and when we're fooling around with these, what we're talking about are um, sines and cosines that that have powers of sines and cosines and other trigonometric functions. Okay. An example. We'll just go through some of the ones that we're seeing here. Um, if we have, let's just fool around with something that looks like n times cosine m x. Yeah. Okay, so n and m are integers. We're not going to fool around with rational parts or any of those other things, but the process isn't too much different for those. But the whole trick here is you're going to be using integration by parts, okay? And actually, you don't have to use integration by parts. You can make life a little easier. You can use a u sub. But remember, when you do a u sub, you got to have a du, right? So let's take a very simple example and say, let's call this 2. Okay? All right. Now, the derivative of sine, so let's pick u to be sine of x. du, derivative of sine is cosine of x. Yeah. Okay. Well, at this point, things come out pretty straightforward. We've come up with u squared and a, remember your du is all of that. So this becomes my du. And now I've got a straightforward integral. Okay? I mean, now it's just u cubed over 3 plus c, and we resubstitute the u back out, and we wind up with sine cubed x 1/3 plus c. And we're done. Okay? That's usually not too bad. That's kind of like the basic starter. Now, if sine were to some other power, say 10, would it be any harder? No, because if it was to the power of 10, then my integral, I'm going to use the same u and the same du that I did a minute ago, and now my integral is just going to be u to the 10th du. So there's no real difficulty when you have something that looks sort of kind of like that, right? No matter what power sine has. Now, if we were to do this in some other direction, let's try, instead of the sine being to a power, we've got a cosine to a power. Okay, so again, picking the right u term makes this a lot easier, because now when you're doing u substitution and you're working it out and you come up with something that's worse than it was to begin with, that means you probably didn't pick a good u, and you got to go back and find something else. So and remember, u substitution is supposed to take something really complicated and turn it into something really simple, right? So let's pick the cosine to be the u. But this way we can kind of boil things down and make it a little bit nicer to work with. U equals the cosine of x. Du, derivative of cosine is negative sine. Don't forget the dx. Now, what am I missing? I need a negative in there. So how do I produce a negative on the inside? I need a negative on the outside as well. So now this is my du, right? And this just becomes u to the 4th. Now I've got negative integral u to the 4th du, so negative u to the 5th, 5 plus c, and I substitute the sign back into it, and I haven't really done anything any more difficult in the last example. So that's pretty kind of straightforward. So the important thing when you're fooling around with these kinds of things is that you want to have a du. If you don't have a du, you're kind of up a creek, right? Sometimes when things, there are things that you can do to massage the problem so that you do have good du. So let's go back before. In the very beginning of this, I had m and n were my two exponents, and one of them, or at least that's two examples, one of them was a 1. Okay? And that made life simple because that was part of my du, right? Well, now let's do something like, say, sine to the third x cosine to the, say, fourth x. Okay. At this point, you might be saying to yourself, whoa, time out, stop, wait a minute. Because my du term is supposed to just be a single trig function. For example, don't write this down because this is the wrong way to do it. Okay. If I made u to be, because either way, whether we chose sine or cosine from the last example, the only difference is that, you know, the math was basically the same, except we had to throw a negative sign in there to make everything happy. So let's just say I don't know what I'm doing, and I'm going to try it and roll through and make the u the sine. Okay. So du, derivative of sine is cosine dx. Well, the problem now is that I've got 4 cosines here. Okay, I've got cosine times itself 4 times. This isn't really good. You know, you might say to yourself, well, all right, Ronco, I could do this. And say, well, there's your 1 cosine, that's your du, right? Well, now that's fine, because there's my u cubed. You might say, oh, hey, I'm on a roll here. And that's my du, but what's that going to be? That's still there. I don't have an answer for that. So this isn't going to work. Okay, we're still left with him. So what we have to do is get it down into a place where there's only a single power of one of them. Okay. So we're going to go back to some of our trig identities to try and see if we can get some of these sines and cosines down from their high powers to something small. Okay. 2, remember, well, the ones that's most important, cosine squared of x plus sine squared of x equals 1. That's the Pythagorean identity. I mean, that's like the most important one that you need to know. So we can rearrange this to come up with 2 other new identities, which are quite useful. I'm sure you all remember. Okay, so using those guys, what I'm going to do is I'm going to find a way to turn either the sine to the third or the cosine to the fourth. I want to make a substitution in there so that I get rid of all but one of them. Which one might be useful to substitute? The sine. You see, if I use that one in here, 2 of the 3 are going to go away. And I'm going to be left with just a single sine. You see? So let's work that out. And you see, this guy is going to come in right there, leaving me only a single one to care about. So now I've got sine of x, 1 minus cosine squared of x, cosine to the fourth of x, dx. And you could be saying to yourself, Ronco, it made it worse. But in reality, it's not. Because now all I've got, once I distribute it everywhere, I've got sine of x times the cosine to the fourth of x minus sine of x times the cosine to the sixth of x. Yeah. And that's good, because now I can take my integral, which looks, now it's not nearly as bad, I guess, but you can break it up into 2 separate integrals and do them just like we did the examples before. And I'm going to save us the trouble of going through those, but those are just U subs from like a minute ago. Okay? Take a second. Are we feeling okay? We all right? Good? Okay. Okay. So, now, one that pops up often is this simple, relatively simple looking. And you might say, well, Rocco, that might just be a U sub, right? I mean, I've got a cosine in there, and you know, that's not too bad, right? Well, okay, let's say, all right, let's make my u into cosine of x. My du is negative sine of x dx. Well, rats, I don't have a negative sine of x somewhere, and I can't make one, okay? Because if I try to make sines out of that cosine, I'm gonna lose the u, right? This isn't really too nice for me, except there is a way around it. And it's, again, using another trig substitution, okay? All right. Let's do this one. Remember this. Remember these? This was cosine squared of x minus sine squared of x. That trig identity. Well, there's another one for cosine of 2x. By using these substitutions from before, I'm going to bring these two back. Second. By the way, that U sub was never going to work, so we're going to get rid of it. Not the right avenue. We need to use these substitutions. So there are two other formulas for the cosine of 2x, and they're using these substitutions. So it's going to be 1 minus 2 sine squared of x, and 2 cosine squared of x. Yeah, minus. Now, these two bottom ones are the ones that are most particularly interesting to us. Because if we, and I'm just going to write out their full forms right here. Both of those are very useful because on one side of the equal sign, I have a squared thing. And on the other side of the equal sign, I don't have a squared thing. Which means that if I have an integral that contains a nice simple little square like the one on the above, I can use these definitions, these substitutions, to turn a squared thing into not a squared thing. Okay? So let's look at the bottom one first, because that one is containing the cosine squared that I have to worry about. And let's rearrange this. Is that your lunch? All right, we'll pick this up after you guys get back. Okay, so I hope everyone enjoyed their lunch. So let's finish this up. There's only a little bit left. Cosine squared is equal to cosine of x plus 1 all over 2. Now, that identity is one that you really, really, really want to put in your brain to use, especially when you get around to the IB exam. Because this question and ones much like it have popped up in the past. Okay? So let's go back to the actual original problem and try and solve it. So we had the integral of cosine squared of x dx. That's the same now as, we're going to pull that 1/2 out. All right. And now, well, first of all, it breaks up into 2 integrals, one of which is just simple x. And the other one, or one, and then when it integrates, it becomes x. And the other one, cosine of 2x, that's just the u sub. And that just becomes x, right? And now for the second one, sorry, for the first one, cosine of 2x, that's a u sub. So u is 2x, du is 2 dx. So we're going to put a 2 on the inside. Okay? And now, there's my du. And I wind up with the integral of u, du plus x. And we resubstitute. Cosine squared of 2x plus x. Oh, out, back to making mistakes. X over 4. Let's see. Yeah, sure. That's a lot. Okay. Yeah. Yeah. My u was cosine of. Ooh, thanks for catching it. Look at that error. That's cosine of u. All right. Oh, goodness gracious. We're all human. I made a mistake. Isaac, however, doesn't make mistakes. I was wondering. I was like, I was doing the derivative in my head to check it, and I realized that I had made a mistake, and I was trying to hunt it down. So this just becomes 1 over 4. The integral of cosine is sine. Uh-uh. pretty sure I'm good on that. So the derivative of sine is cosine. I think that's right. All right, so let's just check it. So taking the derivative of sine is cosine times the derivative of the stuff inside, plus the derivative of that is 1/2. So this just gives me cosine of 2x all over 2 plus 1/2, which is oh, sorry, cosine squared, which is what I want. So I'm good. Okay, remember, you can always check your work by doing a derivative. Okay. All right. Now, last but not least, there is another pair that also applies to this, secant and tangent. And again, the same thing applies, okay? You always want to have one guy left over if you can, okay? So, for example, let's do... Okay? Now, remember, the derivative of tangent is what? Secant squared, okay? And the derivative of secant is secant tangent. Okay. So, all right. What we want to do in a situation like this is we want to try to figure out a way. Now, first of all, there's going to be a u sub in here to deal with the 3x on the inside, right? So what we want to be doing is figuring out a way to either turn it into some power of tangent times a secant squared. Because this is going to be your du. That's going to be part of your du. Okay, if you can get it down to that, that's great. Okay. Remember, any power of tangent at this point doesn't matter. You can do it to the 7th power, because remember, that's just another u sub. That's one possible scenario. Okay. Another possible scenario is having a whole bunch of is taking down and realizing what that secant tangent is the derivative of secant. So you're going to have secant to the n times secant tangent. Either one of these is the form that you're going to want to try to get to. Does that make sense? Now, looking at this, which one of these, the left one or the right one, is a target for this integral? Which one do you think would be the easier way to pull this off? Remember, there still is another substitution that we have. Right? You guys remember the formula, the trigonometric substitution for tangent? That's one of them. Remember what this one was? Tangent squared is equal to what? Come on, you guys. Okay, if you don't remember it, tangent is sine squared over cosine squared, right? Agreed? Right? Now break it apart. And what's one of our cosines? Secant squared. So remember, if you don't remember the trig identities, you can figure them out by just playing around with them for a little while. And consequently, those two. Okay, so those are your toys to play with in order to try and get your powers down to something that works for you. All right, let's look up here for a second. We don't have to worry about the 3x for the moment because when we're done with everything, that's just going to be the final use of. What might we be able to use so that we only can boil this guy down maybe to a single thing? What can we make any substitutions possible? Right, okay. So let's take a pair of those tangents, right? Break that one up. So now one of my tangent squares is still there. And this is going to become secant squared. And we still had secant to the third x, right? Oh, this is all, yeah. Okay. So now let's simplify. So now are we in a better position? Well, if we look carefully, that is his form, right? Now, so that's one integral that we can just push away and deal with, okay? Now we still got to fool around with this integral here. Any thoughts on that? Now, which of those two ideas are we going to try and use for this one? The second one? Okay. That one can be used here. How can we get it in that form first? Well, is it already in that form? No. What do we have to do to it first to play with it? Well, break up the secant. Okay. See what we can do. All right, so first of all, my bell's buzzing on me. this is a u sub here. Where the u was the tangent of 3x du secant squared 3x times 3 dx. I get a 1/3 out in front. Now that integral is already pretty much straightforward at that point. We're getting the last one. Okay. What I'd like to do is I'd like to take this guy, break him up once. Take a pair of those secant powers out, and then substitute in the other place. So, remembering your identities, secant squared is tangent squared x plus 1. And you see now, when I distribute everywhere, I'm going to have what I like. That's tangent to the fourth 3x, secant squared 3x, which was a u sub, plus tangent squared 3x, secant squared 3x dx. Now, first of all, don't forget this integral. We've taken this thing and we've chopped it up into 3 pieces. Okay? And you can see that all of them, this one, and this one, remember, was that one. Okay? They all have to be evaluated individually. Okay? And they're just simple u subs at this point. Okay? All right. This episode of The Ronco Show has been brought to you by Tangent and Secant Squared. And the number 2.